In the previous lesson, we mentioned that overhaul plans for complex, high-precision, large, and key equipment are usually developed using network planning. In this lesson, we will learn together about the application of network planning in equipment maintenance management. The main contents include the following. First, basic rules of network planning. Second, application of network planning. Let's first look at the basic rules of network planning. The basic rules that network planning should follow include the composition and drawing methods of the network diagram, the preparation procedure, and the calculation of time parameters. Let's begin with the components of a network diagram. The most commonly used form is the double notation network diagram. It consists mainly of operations, processes, events, nodes, and paths, routes. An operation is a specific activity process that requires manpower, material resources, and time. In the diagram, it is represented by an arrow symbol. The name of the operation is placed above the arrow, and the operation time is marked below it. Disassembly, inspection, and installation during maintenance are all considered operations. Some activities require only time, without manpower or materials. For example, the drying of an anti-corrosion coating, which is also an operation. There is also a dummy operation that consumes no manpower, material resources, or time. It only shows the logical relationship between two successive operations. A dummy operation is represented by a dashed arrow. An event is the moment when an operation starts or is completed, and it is represented by a circle. It does not consume time or resources, but simply marks the instant of work commencement or completion. Two node numbers together represent a single operation. A path refers to a continuous route that starts from the initial node, passes through a series of nodes and arrows, until reaching the end node. The path requiring the longest time in the network diagram is called the critical path. The operations on the critical path are called critical operations. After understanding the components, let's look at the basic rules of network diagrams. First, no circular paths are allowed, as shown in the diagram. Second, arrows in the diagram must not have identical codes. Third, there is generally only one start node and one end node in a network diagram. Fourth, each arrow must begin and end with an event node. No arrow may branch from the middle of another arrow. Fifth, crossing paths are not allowed. When paths intersect, they should be drawn, as shown in the figure. Once we understand the basic rules, we can begin to prepare the network plan. Preparing a network plan begins with a macro analysis and decomposition of the overall task. Divide the overall task into several subtasks, and then further divide them into operations. After defining the operations, we can draw the network diagram. When drawing the network diagram, first, the layout should be clear and organized, with key points highlighted. Second, critical tasks and the critical path should be arranged as close to the center as possible. Third, closely related operations should be placed adjacent to each other, to minimize line intersections. Fourth, use horizontal arrows as much as possible and reduce diagonal ones. After drawing the network diagram, the following points should also be noted when numbering the nodes. First, the node number at the arrowhead must be greater than the node number at the tail. Second, a node may only be numbered after all preceding nodes connected to its tail arrows have been numbered. Third, node codes in a network diagram must not be duplicated. After constructing the network diagram, the final step is to compute the time parameters. Time parameters in a network diagram usually include the duration of each operation, which is expressed as Tij. Here, I represents the starting event, and J represents the ending event of an operation. The earliest start time of an event is denoted as ES. The latest start time is denoted as LS. The earliest finish time is denoted as EF. And the latest finish time is denoted as LF. The total float is denoted as TF, and the free float is denoted as FF. The total float refers to the maximum delay permissible for an operation, without delaying the latest allowable start time of subsequent operations. For a given operation, the total float is the difference between its latest start time and its earliest start time. Next, let's look at the free float. The free float refers to the amount of time an operation can be delayed or extended, without affecting the earliest start time of the subsequent operation. It equals the earliest start time of the next operation minus the earliest finish time of the current operation. Please pay special attention to these two formulas. In a network plan, the operations with the smallest total float are called critical operations. Now that we understand the basic concepts, let's work through a practical example. As shown in the figure, here is the project data for a network plan. Please draw the network diagram, calculate the time parameters, and identify the critical path. First, analyze the sequence of operations based on their predecessor relationships. Select suitable paths and draw the network diagram. Here we have a sample network diagram. For reference, compare it with your own drawing. Once the network diagram is complete, we can calculate the time parameters. Assume that node 1 has a duration of 0. Node 9 has the same earliest and latest finish times. Let's first calculate the earliest start and earliest finish times. We calculate them along the direction of event progression. For example, operation A has a duration of 2 days, so its earliest start time is 0. Its earliest finish time is 2. Operation B's earliest start time is 2. And its earliest finish time is 2 plus the duration of 3, which equals 5. Similarly, operation I starts at time 10 and finishes at time 16. Since node 9 has the same earliest and latest finish times, the earliest and latest finish times for node I are both 16. Next, we calculate backwards to determine the earliest and latest finish times for the preceding events. Based on these results, we can calculate both total float and free float. The path with 0 total float is the critical path. 1, 2, 3, 4, 5, 6, 7, 9. You can try practicing again using this example. Mastering network planning techniques requires continuous practice and application. That's all for today's lesson. Thank you.